Hello, and welcome to AWCI's webinar. I am Anne-Marie Salvatelli, AWCI's Director of Education. Today's presentation is Why the Movement to Helmets? Should you have a question at any time during today's broadcast, please submit it using the question box in your GoToMeeting dashboard. We will address questions as they come in. Please view the handout tab in your control panel. There you will see a PDF of the handouts to download. Today I am joined by Pete Cheney, AWCI's Director of Safety, Health, and Risk Management. Welcome, Pete, and the floor is yours to introduce our speaker.
All right, thanks very much, Anne. I appreciate that. Welcome, everyone. So today we're kicking off a new AWCI safety webinar series with a presentation addressing why the construction industry is moving to helmets in place of hard hats. And it's a really important topic right now for a couple of reasons, but most importantly because the helmets provide significantly more protection for our workers than the hard hats do, but also because there are already several construction owners, general contractors, construction managers that are already requiring the use of these helmets for head protection. So our presenter today has quite a bit of expertise on this subject. He's a partner at Sales Solutions, and he's invested about 28 years so far serving the commercial construction industry and the industrial safety market. He's going to show us why the change is occurring and highlight the benefits to the companies that make this change. And I can't tell you how many times I've seen George present. I tried to figure that out the other day. I can tell you it's over a dozen, and I can tell you that you're in for a real treat today. So with that, I present to you my good friend and my colleague, Mr. George Stallings.
Pete, thank you, and thank you, and the AWCI, thank you very much for the opportunity to speak to you today on why the movement towards helmets versus hard hats, or as you see in the first slide here, as I like to call it, the purpose of it, the why behind it is really to prevent traumatic brain injuries. And so that's what we're going to do today, is spend the next 45 minutes giving you the why behind it, understanding what happened and changed in the marketplace. And so what I like to do is discuss the big why, the traumatic brain injuries, level set on what Z89 really is, because there's a ton of confusion going on in the marketplace, especially like Pete said in the beginning, there's a lot of owners coming up and requiring different head protection. They're referencing EN 12492. So I want you to understand Z89 at its most basic level. The limitations of Z89, we're going to discuss what led company Clark not only to start to mandate as of August 1st of this year the use of helmets on their jobs, but what led them to being the first company in the United States to move towards it, because I think it's always important to know and understand the genesis of it. I'm going to show you a video that's a comparison between a hard hat and a helmet, and what made the market go away, and why and how the market has responded to it, and the other leading companies around the United States that have made the leap away from hard hats. And I think that the first thing we need to do is understand why the change. And first and foremost, the first bullet point says that the technology is 60 years old. It's actually older than that. The hard hat was invented in 1919. In 1919, they invented the hard hat for its same exact purpose that it's used for today, and it's tested for today, is dropped objects. And so in 1919, they built this thing with some canvas and some fiberglass and some tar and put it together. And still today, it's very similar to that. They did in 1960 have a technological update with some nylon in there. But the bottom line is we've used this hard hat. This technology is 100 years old, or over 100 years old, to do something was never ever designed to do. So we're asking it to do something that has very limited capability. And the why for me, and as Pete said, I'm with Sales Solutions in our company. We focus on really 4 distinct areas of personal protective equipment, and fall protection is one of those areas. PPE is another area, traffic safety and lighting. But we spend so much time on fall protection, we look at those fall fatalities. And last year alone, we had 805 fall fatalities when I combined construction and general industry. And according to the CDC, 50% of all those fall fatalities are related to a traumatic brain injury. And so if we protected the head better, then possibly 400 people would be alive today. And in addition, and part of that 805 is 120 people that fell from that died from same working surface. And then we still had some fatalities from dropped objects, 241, up from 219. And so we are not doing a good job of mitigating fall fatalities in the workplace. And I believe one of the first places for us to do it, and obviously wearing fall protection is critical, understanding the fall protection standard is critical, training is critical. But just like we do in everyday sports and life, we add a lot of PPE to add greater protection, i.e. we get into our car, we wear a seatbelt, we play sports, we put on a helmet, except for the job site. And so in the United States, we have a standard called Z89, and Z89 is, like I said in the first slide, when it relates to the hard hat, and it's a what I like to call a dropped object standard. A lot of people refer to Z89 as a head protection standard. I differ in that statement, because when you, and we'll get deeper into it, a type 1 hard hat takes an impact to 2 square inches on the top of the hard hat itself, the hard hat shell. That's it. The brim, the sides, the back, the front have no means or method to take an impact or mitigate the amount of force coming to the head. It's only the top 2 square inches of the hard hat. That's a type 1. A type 2 will offer lateral protection. Most people like to use the term side head protection. That is incorrect. The lateral under the ANSI standard means it's about 3 or 4 inches above the ear, almost to the crown of the head, but it's a lateral impact that it's doing for a type 2. And so, but both those standards, type 1 and type 2, are dropped objects. They're not about head protection. So that's a critical thing. And so as a country and a society, we really get excited about the fall fatalities, and that's important. But what we don't do is talk about those injuries. And if you look at the bottom of that slide, we had 240,000 fall injuries last year alone. 147,000 of them were sand working surface. That's slips, trips, and falls. That means I'm walking around the corner and Pete decides to put his foot out and trip me. I hit the ground, I hit my head, and I get injured from that head injury. 35,000 of those, in addition to the 147, were same level without a fall. Now, that's not my terminology. That's the terminology we get from the BLS, the Bureau of Labor Statistics. I can only assume that somebody falling, not quite hitting the ground, but maybe hitting a fire hydrant or hitting a piece of equipment, but not hitting the ground. And 52,000 injuries were elevated. What should we see those fatalities? They were elevated fatalities or elevated injuries. And what makes that injured person, in my mind, more of a, I don't want to use the word problem, but more of a greater issue, is how it affects the greater family unit and everyone around them. When someone dies, obviously the fatality is final, and we have to grieve, and we start to deal with life without that person and without that loved one. The problem with the injured worker, especially if that injured worker the injury is severe enough, their extended family life changes as well as the person who was injured. And sometimes they're not just simple injuries. Sometimes they're catastrophic injuries that person can't walk, they can't remember, they can't go back to their job. And that's what led to this big change. And so not only does that person who was injured, their life changes, their wife, their kids, their husband, their support group all changes. And so I think that we have to look at those injuries as a greater hazard. And 240,000 is almost 250,000 workers each year are injured from falls. And if I take that same number from the CDC, where 50% of fall fatalities are related to a traumatic brain injury, then I could assume, and I'm assuming here, that half of those 240,000 are traumatic brain injuries, and that's around 120,000 individuals walking around, or maybe not walking around today, with a traumatic brain injury that we could have prevented if we just changed their head protection. And so, again, this is our American standards. ANSI type 1, top of the head, top 2 square inches. ANSI type 2 is a lateral, high side impact, and as well as a top of the head. Then they have 3 classifications of the hard hat. Class C means conductive, a vented hard hat. So anything with holes, regardless if those holes have a metal screen in them, doesn't matter the type of hole it is. If it's a hole in the shell, it is automatically going to be a Class C. Class G is general, that's 2200 volts, and Class E is electrically rated, that means 20,000 volts. Most hard hats, 90% of the market is Class E. That is a non-vented, electrically rated hard hat. And so that's important, understanding those 2 things and what they can and can't do. And so what I wanted to do is, because of the confusion out there, is just give you the for lack of a better word, the preambles on both standards that I'm going to start level setting everybody today. And so when you look at the ANSI Z89-2014 standard, revision 2019, that was the latest revision we've had on the standard. A typical ANSI standard gets re-upped every 5 years. And on page 1, under limitation, it clearly states helmets that meet this standard provide limited protection, but should be effective against small tools, small pieces of wood, bolts, nuts, rivets, sparks, and similar hazards. That's it. Notice they're not saying protects the head. It is a drop object standard. It says it right there on the preamble. On EN 12492, which is often called the mountaineering standard, that's the European standard. And we, as I always say to people on these talks, we do not have a head protection standard in the United States, and in Europe they do. And when they work at heights, they use this mountaineering standard. And 12492 2012-04 on page 5, and under the introduction, it states a proportion of the energy of an impact is absorbed by the helmet, thereby reducing the force of the blow sustained by the head. The structure of the helmet may be damaged in absorbing this energy. So you see reference to the head in 12492 and no reference to the head under Z89. And that's really important, is understanding the genesis of both standards and what they're designing the head protection to do. And what I'm asking people to do is refer to a hard hat if you're looking at something that's Z89, and something that's 12492, refer to it as a helmet. And hopefully we'll start seeing ANSI start doing that. Much like we differentiate between a bump cap and a hard hat, I would like us to start having a third differentiation under the standard to say bump cap, hard hat, and helmet. And helmet being something that has a chin strap that can deal with falls, that can deal with, more specifically, a front impact, a rear impact, a side impact, not just a lateral, and a top impact, and stay on the head during a tumbling fall. That's what I would like to see. And so this is another slide, just kind of really dialing into two standards under Z89. So types, I should say, two types. So again, type 1, top impact, penetration, it gets tested, and you'll see this in a video. Flame resistance and electrical certification, and you'll see that electrical certification under all 3 classes. Now, they do not test the conductive version or the vented versions. They only test general and electrical, which is 20,000 volts. Type 2, you have lateral impact protection, lateral penetration, and chin strap requirements that are optional, not requirements. So if you do have a chin strap, then you have to have a release similar to 12492. And it also has low and high temperature ratings for work at height. So that's what they want. And this is that the 12492 standard really dials in. And it is a climbing standard, and they call it the mountaineering standard. And on the bottom, you really see what they're testing the helmet for. This is really what it's designed to do. It deals with a top impact. If you look from, I'm going from left to right on the green helmets, you're looking at the next one. So it's a 5 kilogram falling mass. Then you have a 5 kilogram pointed penetrating impact. Then you have front, side, and back impacts. Then you also have a release requirement and a stretch requirement of the chin strap. So the chin strap must stretch and the chin strap must release at about 100 pounds. And so it alleviates the chance for strangulation. And then there's the last test, which is a pull from the back of the helmet to make sure, and you're dropping it with 10 kilograms, so it doesn't pull off the helmet. Remember, what the helmet is designed to do is to stay on the head during a tumbling fall, and in an effort to protect the head. That's the goal. And so there are some people, when I say people, organizations is a better word, that are requiring type 2. And I think this is a step backwards when we talk about type 2s. Type 2 is part of the ANSI standard, as you already learned. But why do I feel that there's limitations? One, it's still a dropped object standard. They are definitely heavier. So you're using the same shell you used under type 1, and you're adding a lot of foam to it to make it, and it's a bigger product. It does not have a requirement for a chin strap. So they do require a suspension change annually, like a hard hat does. So if you do use current hard hats and you decide to go to type 2, you'd still have to replace your suspensions annually, which come for a greater cost and greater management of your PPE. And they're not tested for falls, and they're bigger. And so we're putting a greater weight on the worker, and we're making a bigger product for PPE, which makes sometimes work more difficult, especially when we work in confined spaces for up in data centers and places where I have a lot of pipes and chases. If I'm getting there to put the drywall in and structural steel, makes life difficult if I have a larger head protection on to do my job. And the other part is I always like to look at the instructions. You'll see this theme come out in this presentation. I always tell people, no matter if it's fall protection, head protection, eye protection, read the manufacturer's instructions of the product you're purchasing. This is vital. I'm a salesperson, and I always say to people, don't believe what I say, believe what's in my instructions. If my instructions say it, that supersedes anything marketing says, and that supersedes anything that I'm saying, unless you have a letter from me or one of my engineers to prove, to say something different. So these instructions are critical. And so this is a type 2 hard hat instruction from a manufacturer. And the highlighted part where it says, although, and this is a type 2, although this helmet meets the passive retention test of Canadian standards and CSA standards, so the type 2 standard was adopted from Canada, in some extreme conditions such as high wind or helmet impact, it can dislodge the helmet from the head. And a fall is a high impact. And then, although it may provide, up on the upper right-hand side, it says, although it may provide limited head protection in event of a fall, this helmet is not designed for fall protection. That's critical. So the makers of type 2 hard hats are out there saying right in their instructions not to use it for fall protection. When you buy a helmet that is rated properly under 12492, it can't use that terminology saying not to be used for falls. It has to be used for falls. It has to be certified for falls. And then this is the instructions that you see from the manufacturer. So suspension, replace no more than 12 months. So you have to replace it once a year. An entire helmet has to be replaced no more than 5 years. And they say these are maximum service useful guidelines. Wear or damage notice before a year, for clarification. Inspection must be a determining factor for possible early replacement. So that means if you have any damage to your internal suspension or wear and tear, you must replace those things more often. So it does have some comparisons. And so what we're now taking to the market is saying, and this is what we started with Clark, is saying, let's have a head protection that meets 2 standards, meets both EN 12492 and the American ANSI standard. I like type 1 because I'm marrying 2 standards, one for dropped objects and one for fall protection. And when I do that, if you look at this chart, I'm getting every block filled that is critical to someone surviving an impact. And so this is just a general difference. Now, we do test with heavier weights when it comes to 12492, which means it has to dissipate more force, which is great. So we're giving a person greater head protection. We do protect for front, side, and rear impact. Under type 1 and type 2, we don't do front and back under type 2. And so there's limitations there. All standards have top penetration. The 12492 doesn't have a flame resistance, but ANSI type 1 does. And under Class E, you would have to rate it for 70E, which does arc flash, which is 32,000 degrees, which is pretty high amount of temperature it has to deal with. We do have a retention standard. That chin strap retention standard is critical. And if you look at it, the retention standard we both have the same elongation of 25 millimeters. That's the stretch. And they both have similar release weights, which is important that the chin strap does release. And so when we marry those 2 standards, we really are getting the most head protection we can afford ourselves. And that's really the goal, is to protect the worker from a traumatic brain injury. And so that's what we're doing. This is the better approach, is taking Z89, using it for dropped objects, combining it with the N12492, and then we have head protection that can deal with the impacts to the front, side, top, and rear of the helmet. They will exceed current standards for shock absorbency, and it will stay on the head for tumbling falls. And so those are critical parts of it. And these are the differentiations right here, just a reiteration of what I just said. And the differences between the 2 standards, or the additional features you get, is you'll see in the green 1, 2, and 3 in that graph. You get a helmet that can deal with the front, side, and back. You get a helmet that can deal with, that has a chin strap and a release. And you have a helmet that doesn't fall off your head in the event of a fall. And this is a nice comparison between the 2. So in general, for time purposes, this gives you an understanding quickly what's the difference between a hard hat. A hard hat is designed for falling objects only. It has a 5-year life, and it has a headband or internal suspension that has to be replaced annually. A helmet, like the cast that I'm talking about today, that one is both Z89 and 12492. It is designed for fall protection and heavy impact. It has a 10-year life, and there's nothing internally that you have to replace on a annual basis during that 10 years. They do have sweat bands inside that you may want to replace for hygienic purposes, but there's nothing structurally in the helmet that you have to, under the cask helmets, that you have to replace. Marianne, I have a flashing question. I don't know if there's a question, if you wanted me to break here.
Hold on one sec. I don't see one that came in.
Okay, I see. Okay. Maybe that's just my screen. Okay. So this is the, hopefully everyone's level set now for time. I hope I didn't move too fast through the standards. But this is what led to the change. And back in 2015, Clark had an accident at their job site. And so what I'm going to go through is their process, or as a word people like to use today, is journey to changing head protection within Clark. And that's what led to everyone changing their head protection in the United States and going down this path. And so what happened? So this worker, this was a big project in Center City, DC. The worker was up 4 feet on the scaffold, and everyone on the call right now will know that in construction, the fall height requirement is 6 foot for fall protection. This worker was working off that scaffold. And the gentleman who really had to deal with this for Clark, his name is Seth Randall, who led the movement in Clark and as well as nationally for head protection change. He would tell you that the scaffold was in bad shape, and there was about 3 or 4 things that failed that day before that worker fell. In other words, they didn't need to be back in the basement when they were well above that basement stripping something. Someone left something behind. The worker shouldn't have used the scaffold in such disrepair. And so there was a lot of, he shouldn't have been working alone either. But nevertheless, he fell. And when he fell off, his hard hat fell off and he struck the head. That's the blood you see on the floor. And unfortunately for that worker, he was a few blocks away from GW Hospital, or George Washington Hospital is the same hospital that Ronald Reagan went to when he was shot. So it's a shock trauma hospital. He was put into a drug-induced coma for 3 nights, and Clark really didn't believe he was going to live from this 4-foot fall. So they flew his son in from California, who he hadn't seen in 12 years, to say goodbye to his father. They were minutes away on the 3rd day of getting ready to saw open his head, his skull, to allow the brain to swell in an effort to save his life. And fortunately, he did live. But unfortunately, he never came back to work in construction ever again. The direct cost of this accident, and still open, believe it or not, today, was the direct cost of the accident was around a little over $450,000, and there's they'll probably settle in the millions when it's all said and done with this worker. And so there's a lot of tragedies when you look at what happened here, and that's why Clark made the determination at that point they were never going to let another worker on their job sites get hurt from a traumatic brain injury because of this event. And so that's when they started a 1 year long process looking for better head protection, because what they noticed is that every time they had a fall, the hard hat was off of the worker's head. And so the first thing they did was buy better suspensions. They went to the ratchet suspension. They were using MSA V-Guard for their head protection before. And so they bought ratchets for everybody, hoping that was going to stay on the head. And that really wasn't, as you'll see, you'll learn. But the one thing they did pick up is that when we were going through this process, is that as a society, we spend more money on protecting our feet than we do our brain. And if you think about it, in construction, a general hard hat costs about $10. But you'll see folks go to Red Wing stores and get really pumped up about their Wolverine boots or their Caterpillars or their whatever brand it is, Timberlands, and be really excited about how much they spend on their boots and proud of it, and rightfully so. But when it comes to head protection, we spend about $10 on a hard hat, and that the brain is our CPU. And so that controls everything. And so I always like to tell people, you can't wiggle your feet unless your brain's working. So we really should take pride in offering better head protection, and that's so the person can continue to work and continue to function in their life when they have their brain protected. And it's also another funny thing that Seth likes to bring up is that people spend more money to protect their cell phones on cases than they do their brain. And so we need to flip that. In construction and general industry, we tend to use the least amount of funds to protect our most important part of our body, and that's our brain. And so and this is when Clark was going through this process, they started to really dive into what a traumatic brain injury was. And as the CDC says, it's a traumatic brain injury is a blow or jolt to the head or penetrating injury that disrupts normal brain function. And the ranges are brief, mental status or consciousness, to severe and extended period of unconscious amnesia or after the injury. And the problem with a traumatic brain injury is it's not like any other injury we see that we see in construction specifically. Like if I was picking up a piece of light gauge and I cut my hand and I need some stitches, in a few weeks those stitches and that laceration starts to heal, the doctor comes by and removes the stitches and you start to see the healing happen. That's a problem with the brain. We can't see the healing happen. And a lot of times these injuries that you see listed here are permanent. Just like the worker with Clark, he fell and will never come back to work because he doesn't have the same brain function he had before that accident. And so traumatic brain injuries are very difficult. And if you look at other industries that are experiencing traumatic brain injuries, much like the NFL, and the NFL, they spend $100 million in settling with the players union for traumatic brain injuries. Their traumatic brain injury is CTE, and that comes in the form of injuries later in life from those concussions that the players received, like Alzheimer's, like Lou Gehrig's disease, like dementia, a lot like what you saw Muhammad Ali go through later in his life. But one thing that they don't share with construction is they've never killed somebody on the field over 100 years. Well, we've had, obviously last year alone, we had 400 deaths from traumatic brain injuries in construction and general industry. And so the NFL is spending a lot of money to protect the brain, where in construction and general industry, we do not. And so this is what Clark saw as a difference. On the right, you see the traditional hard hat. And on the left, you see the cask helmet. Big differences in suspensions. So the nylon, I like to call it an air gap suspension, because you'll see in the video how it truly takes that energy away, versus the foam, which you see in every form of head protection today. And so realistically, the nylon suspensions were used in the 50s and 70s, especially if you were in the military or playing sports. You would see a lot of these nylon suspensions. You won't see it after 1970 in any other sporting events. You see foams like you see on the left. So that type of head protection left us in 1970 and any other action, with the exception of general industry and construction. And so that's the big difference between a helmet and a hard hat, as you see functionally right there. This is a study they did about the suspension systems, and you can see here in the study that crash helmets that used to use in the 70s, suspension helmets, ceased doing that and moved to what we're using now as EPS, is expanded polystyrene. And that's what you're going to see in a cask helmet, is expanded polystyrene. It's just a newer product, and you'll see it in, like in this slide, a motorcycle helmet, you have a lacrosse helmet, and an equestrian helmet, or I'm sorry, a skateboarding helmet. In this picture, you see football helmet, lacrosse helmet, and hockey helmet. All of them have contact EPS foam. When I say contact, it means that the foam or the shock absorbing material is touching the head and making contact with the head, not like nylon suspensions that do not make contact with the shell in the head. So these are functionally a lot different than what you see in hard hats, the way we protect our heads. And I'm sure that the people on the call today protect their kids differently than you protect your own head with a hard hat. So I hope that when your kids ride a bike, you're putting a bike helmet on, or they're playing lacrosse, you put a lacrosse helmet on, or where you go skiing, you wear a ski helmet. And you can look at people like Sonny Bono, and you can look at how society changed 20 years ago when Sonny Bono was skiing and he struck a tree with no helmet on and he died because of that injury. And today, if you went onto a ski resort, you would find everyone wearing helmets. And it was that one event that changed everything. And Sonny Bono changed and probably saved many lives, giving up his for people wearing helmets on ski resorts. And I think back 20 years ago, if you walked onto a ski resort, you would see nobody wearing a helmet, just like Sonny. And unfortunately, he was the tipping point to head protection in skiing. And we see tremendous strides in head protection and all other facets of life. And we want to be that to help everyone else move their head protection forward. This was a study that NIOSH did back in 2016. They released it, and the study period was from 2003 to 2010. And it basically stated what I was stating, that the traumatic brain injuries in construction during that study period was around 2,220 fatalities from traumatic brain injuries during that study period, which boils down to about 50% of all those fall fatalities. And so the study was pretty interesting. And this is all the information that Clark was doing and finding out when they were looking towards head protection. And what they found, they showed me this study, and they found out in the study that frontline supervisors where there was 179 of those 2,200 were frontline supervisors. Construction laborers, very high, 559. We would figure the laborers are high, their exposure is high, but I was still blown away by the amount of supervisors we had that died from traumatic brain injury. Structural steel iron workers, they're high up at heights. They were actually rather low when you look at in comparison to supervisors. Roofers high. We know they're going to be high. Drivers, 73 drivers. And then at the end of the day, if you look at this last bullet, 3/4 of all fatalities were from roofs, ladders, and scaffold. And when I look at the BLS every year on fall protection, same thing. It's roofs, ladders, and scaffold. So when we're working at heights, our incidence of fatality go way higher. And so that's when we really need to look at our head protection and change it as well in there. And this is what NIOSH found out. And they agree with the precipice or the premise that I'm bringing up right now, is that although helmets, and they should say hard hats, in construction work are intended to protect workers from falling objects, penetrating hazards, and electrical shock, they do not always provide sufficient protection against falls. And I would go one step further. They cannot protect against falls. They have no means or method to protect against the falls, especially when the hard hat has no means or method to protect against front and back impacts, where most likely the worker is going to fall. A lot of times, if I fall to the side, my shoulder protects my head from hitting the surface I've fallen onto. But I don't have that same protection when I go to the front or back. And if you look at the ladder falls, that's where that worker is going to most likely impact, is the front or the back of the head. And so NIOSH said this back in 2016. And so that year process that Clark was going through, working with a cross-functional team, when I say cross-function, it wasn't only safety. It was a lot of their superintendents, a lot of project managers. It was really a true cross-functional team that looking at, they worked with 10 different manufacturers of head protection around the world to try to drive towards better head protection. And for Clark Concrete, which is a smaller division of Clark Construction, they were the ones who had the first injury, and they call this one the last straw. This was about a year after the first injury when they were going through their study period of different head protection. And this worker fell off this piriform, and you can see his fall protection engaged. And if you look closely in that picture, that's not a handkerchief in red that he's wearing around his neck. That's the blood from his head. His hard hat fell into the stones, and he had 24 stitches. And at this point, one division of Clark decided, Concrete, was about 600 workers, decided that they were stop using helmets or hard hats at that time, and they were going to the cask hard hat or helmet at this date. The problem was there was another 3,000 workers at Clark that Seth Randall wanted Clark Construction Company to move. And obviously, like everybody, cost is a factor. And so the head guy at Clark said, look, I believe that Clark Concrete should have helmets on, and we support you moving to helmets versus hard hats. But you have to prove to me, and I want to believe that these things are better. So they decided to send the helmets and hard hats to a third-party lab in the United States that does ANSI testing. Because the first two things, at the time, cask was made in Italy, and they wanted an American lab to substantiate what we were saying. And they also wanted to kind of prove that the hard hat was every bit as protective as the helmet. And so because if they can prove that, then Clark Construction in their mind could stay in hard hats, and Clark Concrete to move to helmets. And so they sent him to a lab, and I want everyone to understand that this video that I'm going to show is proprietary. Clark lets me show these videos because they want more people to go to a better head protection, but I can't give it out to people. And so they took the pictures, they took the film. No one from cask was there. They paid for everything. And when you do an ANSI test, you need 30 helmets and 30 hard hats to be destroyed. So as one cycle of testing, you need, in a sense, Clark had to buy 60 products they were going to destroy, 30 helmets and 30 hard hats. And so Clark made that switch because of those videos, and then you see a lot of the other companies now around the United States moving towards helmets. Not just construction companies. You see people like Virginia DOT. You see Xfinity or Comcast moving. They're not just big general contractors. There are some very large subcontractors, Largo Concrete that you see out there. And you'll see just many contractors around the United States making moves into Allen Myers as a road builder, as opposed to a general contractor. So you see a lot of different contractors out here, AWCI, GC, Hensel Phelps out there doing the same thing, ISEC electrical contractor, PCI, drywall contractor. And so you're just seeing a lot of different folks making the move towards head protection. And that's what I like to kind of show everyone. It's not just general contractors who don't have that exposure making that move. And these are the different types of helmets that we represent. So we do have vented ones. So like I said before, we still rate them as type 1, not type 2, even though they can deal with the side impact. And the ones that have vents are class C. The ones that do not have vents are class E for electrical. We do not make a G-rated helmet. The other thing that people like about them is they do have eye protection and accessories. We really built the helmet to be a platform for total head protection. So you have earmuffs for your ears. Then you also have visors. These visors are primary eye protections. They are Z87 plus rated, so that means it can deal with high velocity. So if someone's using a gun to put their fasteners in, they get the protection that way as well. And we have a little gasket on top for debris protection. And you can see there's different types of accessories you can put on your helmets. The other thing that's happening in the marketplace today is you see a lot of manufacturers, like you see on this slide, bringing out products that look like helmets but are performing like hard hats. And this is what I said at the beginning. The one thing I want to get across is, yes, there's a way we can go to greater head protection, but more than that, please read your instructions. And the first one, this pricing is no longer good anymore, but I like to read their instructions, because this one company, I think it's Pyramex, they write in their marketing data, they talk about that slips, trips, and falls are dangerous, and they create a lot of hazards. But then in their little bottom that you probably can't see, that I'll read to you, and it says that this helmet is designed for 397, that's EN 397, that is a Z89 equivalent, but it's not, it's only rated for top impact only. So that means it can only deal with a dropped object. And so if you see that warning, and I'll give you a better warning, this one's off of the MSA helmet, and it says this helmet in the middle of it supplies limited protection from impact and penetration to the top of the head. This helmet is not specifically designed to protect against front, sides, or rear or lateral blows. It's important that you read these instructions, because if a marketing literature tells you that it meets some subcomponents of 12492 and they have this warning in their instructions it can't do front, side, or rear impact, then it's certainly not 12492. And that's critical that you read that. And then you go further, it tells you that you have to replace the suspension on the bottom line. You have to replace the suspension every 12 months and the shell every no more than 5 years. So it has exact same performance criteria as a hard hat, but it looks like a helmet, it acts like a helmet, but it is not a helmet. We have another one here that you have to replace the chin strap annually as well on this piece of hard hat. This is another one from 3M. They have one that looks a lot like a helmet, but it says right in their instructions, type 1 helmets do not rely on type 1 helmets to provide front, side, or rear impact protection. So you could be fooled into believing that something looks like a helmet, but it's certainly just a hard hat. And I would warn you to look at what you're buying first and read the instructions before you go out and make a big purchase, because these helmets do cost more and you want greater protection for it. You deserve greater protection, but make sure you read those instructions when you go out in the shop for the product you're looking for. So I'm exactly at 45 minutes, Ann. I'll open it up to any questions.
Perfect. Thank you, George. We do have a few that came in. This first one is 2 parts. So they're asking, is deflection not a thing anymore? And our helmets, do they not provide deflection?
What do you mean by deflection? I'm not quite sure what the person means by deflection.
I think they're probably referring to the brim on the hard hat.
Okay, yeah, so the brim doesn't have any kind of structural protection on the hard hats, and as you notice on the helmets, we don't have brims anymore. So there is no test on the brims. The brim is purely there for keeping the sun out of your eyes or rain off of you, but there is no structural integrity to the brim. It doesn't get tested that way. So it's more there for aesthetics and maybe keeping the sun out of your eyes.
Thank you. And then Ed is asking, are you able to share a copy of the presentation? They'd like to share it with their management team. Is that something?
Yeah, and Anne has a copy of this. We're giving it out in PDF form, with the exception of those videos. But I'm also available for anybody. If you want the same webinar to your company, I can deliver that for you as well.
Awesome. So I'll get you both connected. And next question, what do you do for welding hoods?
Great question. If someone texts me or emails me, the product I like the best for welding is a product from Lincoln. One of my iron workers in Virginia found it for me. It goes right into our ear slots, so you don't have to do anything else. So in the helmets, we have earmuff slots. I don't know if you can see my webcam. Hopefully you can, on the sides here, and it's a Lincoln welding shield that'll fit right into those slots, and it goes in nicely and works perfectly with the helmet.
Thank you. A couple more questions here. So if Type 2 is an American standard, why shouldn't we use Type 2 hard hats?
Because Type 2 doesn't offer the protection that's really needed for the workers. Type 2 is only offering you a high lateral protection. And the high lateral protection is limited to dropped objects, not true head protection impact. And so that's why 12492 is a greater standard. It offers you more protection because it's giving you testing and giving you protection against a front, side. In other words, all around that shell, you're getting protection, where a Type 2 is not tested for that. And Type 2 doesn't require chin straps. It is an accessory item. Now, when it's made with an accessory, as an accessory, you have requirements you have to meet, but it's not a requirement. And so when people add chin straps aftermarket, they don't get the same protection as a chin strap brought in by the factory. So for two reasons: one, there's no front or rear impact on a Type 2, and then the chin strap requirements, for me, mean that that Type 2 is incomplete, and 12492 offers just such superior protection.
Thank you. Second one here, I think this may touch a little bit how Pete was talking about deflection and brims. So this one is, I like having a brim because it protects me from falling objects. Why doesn't your helmet have a brim?
So ours doesn't have a brim for various reasons. One, when someone's rigging, working overhead, the brim gets in the way. The brim also gets in the way of us putting some of the eye protection we want there. But most importantly, the brim does not have what Pete was referring to as impact protection. So if a brim was struck by a dropped object, it would drive itself into your nose. So it's just a misnomer that the brim does anything other than keep the sun out of your eyes. So we don't use a brim for those two reasons.
Okay. And then looking at the foam, the EPS, their comment is it looks hotter. Is it hotter than a hard hat?
Well, that was the first complaint that came to us from Clark and other companies. It was hotter. So then we took it to an NFL lab, and the NFL lab tested. An NFL lab was in Georgia, and they put it in. It was 105 degrees at 80% humidity, no air movement. And so our vented helmets, our C-rated ones, have vents in them. They actually came in 2 degrees cooler than a hard hat, and so the hard hat came in at 105. Our vented versions, the Zenith Air or the Super Plasma, came in at 103, and our Zenith, our electrical rated helmet, came in at 105.02. So it was 0.02 hotter. Very hard for the human being to pick that up. And the most important thing that the NFL lab told us is most of the heat is perception. A lot of the football players, when they changed head protection, complained that they got hotter. So the heat is really coming from two places: the human being who's wearing it, not necessarily the outside air, but also the feeling that they're hotter. So perception is reality. So it's more about the education. So we are technically and factually not hotter than a hard hat.
Okay, thank you. That looks like all the questions that came in. So I want to take a moment and thank all of our attendees for joining us for today's presentation. And as you close out from the webinar, we will have some questions pop up on your screen. And George, if you have one more minute, Amber's asking a question here. What would be the main selling points between a cask helmet versus a Stetson helmet or any other type 2 helmet meeting the EN 12492 standard?
Stetson uses a different technology. They've been in the head protection business for all of 6 months. I'm not sure where their background is into that. We've been in the head protection business for, I think, 30 years. Our background at cask is in the performance head protection. That's all we do. And there's other products out there from power tool manufacturers and things like that. And I really question their expertise in head protection. But for cask, let me speak directly on that. So we're in the head protection business and performance in 3 areas before we got into the construction side. Those 3 areas are bicycling, skiing, and equestrian. And equestrian being the hardest way to protect someone's head because that rider is falling off of an elevated animal that's around 2,000 pounds that could possibly fall on that person as well. And so we offer some of the best protection there. Skiing, obviously, we talked about that, and bicycling. And you look at a professional cyclist, and they're running around 55 miles an hour in a peloton. The only protection they have on is a helmet, and we're the #1 brand in that sector. None of those places does Stetson get some expertise. And so we get in performance sports, we get to take all of what we learn in sports and apply it to our industrial athletes. So cooling. So remember, in bicycling, we have to cool the athlete. We have to make that athlete perform better, and we also have to make them aerodynamic, and we have to keep their head protection light. We can take all that technology we learn in all those 3 other verticals we are experts in and leaders in and apply it to construction safety. I don't think the tool manufacturers or companies like Stetson, who've just entered the market to bring a product, have that background in head protection that we do.
Thank you. And one more item someone just wanted to share here is that this particular contractor, some of their clients use cask helmets and started requiring type 2 helmets by AWCI, but theirs is a type 1, and this individual just wanted to share that they think there's still a lot of them are still confused out there.
They are. Whoever says that, you're correct. I think there's a ton of confusion between the 2. And so the reason we could pass a type 2 test, the reason we don't certify ours to type 2 at this time is the way the Italians, and for clarity, when we first came in the United States, all of our helmets were made in Italy. Now we're making our helmets in Chicago in the United States, fully made in the United States, not with parts from overseas. We were reading the standard. There's because we have an ear notch out that comes, the part of the helmet comes around our ear. We believed we had to have a line that came across like a hard hat does, a static line to measure up to do the impact for the type 2. So what we believed is that we couldn't draw an imaginary line to join where the notch outs were. So we'd have, where the helmet goes around the ear, we would have to have a point here and a point here. And we believed that we couldn't draw an emergency, an invisible line to measure up to do the test. And so we did not certify that from a technical design criteria to type 2. A type 2 impact, we will pass all day long. So if I hit the helmet with a type 2 impact weight, we'll pass with flying colors. In fact, we test our helmets to a greater standard in Europe called 14052, which is twice the amount of weight that type 2 hits with, and we pass that test. So performance-wise, we would pass type 2 all day long. Design criteria, we felt we didn't meet it, and so therefore we wouldn't certify it. Now, Stetson and another tool manufacturer have that same ear knockout. They certify the type 2, so we're talking to American labs to see if we're reading that standard wrong. And you know, so we're still going to hold to what we feel is, unless we hear otherwise from an American lab, that we can now certify the type 2. But impact-wise, energy-wise, we have no issues with it. It was just design criteria. I hope I answered that question. And they are correct. There's so many safety professionals don't understand the difference between the two standards. And I hope today I went deeper into it enough where people can understand the difference in type 1 and type 2.
And George, if you have another minute of your time, just Brian typed in here, if I understand correctly, you are saying a helmet with an ANSI type 1 and EN 12492 certifications offer better protection than a type 2?
Absolutely.
Okay.
Unequivocally, yes.
Awesome.
So keep in mind that 12492 standard, you have to get a certificate. It just can't be because you said it. Europeans require real test data, so that's why I read their instructions. You know, and you see these presentations when I use CASC slides. It said CASC on the bottom. We say radars for falls. Other people use those terms. Do not use this for fall protection. So really look at those instructions. If someone's claiming 12492, they can't have any of that language, not for front rear impact. That's the critical thing.
A lot of good information. So again, thank you to all our attendees, and thank you, George, for sharing your time, your expertise with us. A lot of good things for everyone to take back. A recording of this webinar will be distributed to all the registrants tomorrow, and we'll put it on our YouTube channel. So again, thank you, everyone. Stay safe out there and have a great day.
Thank you.